Chapter 3, Section 2, last page. The last of the different types of basic truth tables would be biconditional. Remember, biconditional is if and only if. So I wanted to point out in the last one, I did the other basic tables. And remember, in the basic table, the first statement is always P and it's always this order. And Q is always the second one and it's always this order. These are all the different possibilities of having a compound statement with two simple statements. So true, 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 false, false, true, and two falses. So these two columns are the same in all the basic compound truth tables. Okay. It's the last that has the symbol for, conjunction or conditional, biconditional, etc. is the different thing. Okay. So as we go through the biconditional, the first simple statement is the Cubs make the playoff. The second, they happen to make the Cubs win. So remember, it's not what you think should be first, it's what they say is first. So we're always looking at the first statement as true or false. And if that's true or false, and if this is true or false, then what is the biconditional statement? Is it true or false? So if the first statement is true, the Cubs make the playoffs, and the Q statement, the second simple statement, is true, the Cubs win, the Cubs make the playoff if and only if they win. That's true. Okay. If they make the playoff, but they did not win, right? It's false that they won. Then it makes sense that the biconditional if and only if Cubs make the playoff if and only if they don't win is a false statement, compound statement. Okay. So the next case, let's say the Cubs didn't make the playoff, but it's true that they won. So that makes the compound statement if the Cubs don't make the playoff if and only if they win. So that doesn't even make any sense anywhere. So that's a false. And then they didn't make the playoffs. They didn't win. So that's true. Okay. So a biconditional statement is a conjunction of two conditional statements tied to each other very strongly. So if P then and if only Q is true, then both P and Q are the same truth value. So if you have a double truth, it's true. If you have a double false, it's true. Otherwise, the biconditional compound statement is false. Okay? So we went over all the basic different truth tables. Now let's try to use them in some examples here. What I like is I found this little kind of instead of having all of the truth tables in front of you, there's a way to combine them into this little note sheet that you should have handy all the time. If we were, I'm sorry, I'm thinking through different scenarios here. Let me just remind you that, remember I said the first two columns are always the same. So look at the difference between, so biconditional, that's this column. So this column that we put here, I put here. And these two that are always the same in all of them, they're here. So this is the conjunction. This one's the last column in the disjunction. This is the last column in the conditional, and this is the last column in the biconditional. So this is kind of the shorthand version of the of the truth tables. Okay, that way you're always sure what you're following. So when you come up with um, constructing a truth table of whatever they're asking, always start with the PQ columns that are the same, then any negations that are needed, and then use the reference to figure out the values in the proper order to find the truth table, the rest of the truth values. Okay. So I'm trying to find if this is true or false, this compound statement here. So what I want to do is construct my own truth table. And like it says, you start with the P's and the Q's. Okay. So again, this is always T, T, F, F. This is always T, F, T, F. True, 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 false, false, true, false, false. All the different possible combinations. Okay. That's what it says. PQ columns. Then any negations. So if there's a negation here, what I need is that negation as a column. So then I refer back to the P. If P is true, then negation of P is false. So that's a false, false. If this is false, then that has to be true. So I'm referring to this here for a negation of P. Okay, so negation of P is always the same as well. Negation of Q is always the same. Okay, but I need them for this one. So now I have everything I need because I need the Q and I need the negated P to get the one that I'm looking for. And the, excuse me, the disjunction, that's an or, right? Disjunction of a not P and a Q is what I need to find. Okay. So what I'm looking at here, if I want to do it a little shorthand, before I write that in there, I'm looking for the not P, which is false first. Okay. And then I'm looking for the Q, which is a T. So it's FT in a disjunction. So if you look at the disjunction table here, right here, you have an FT. FTs are true. Okay. And this one is a not P, which is an F. And I do this so I can get them in the order that they're supposed to be in. So an FF is a F. All right. And then a true and then a false. Wait. A true and then a true. And then a true and a true and a dish here. Let me get the other table out just in case you're not following this here. A true. Look, a true in a dysfunction or an or is a true. Okay. Not P is T. Q is an F in this row. Okay. And then in the disjunction or table, you have a T and the F, then it's true. Okay, so if this is too hard to use, go back to the original tables. So in your homework, this is what they want. Do not write this stuff. They just want to know this last column here. They do have places to put optional columns. I just write it out. I'm showing my work. This is how I got this. Okay, and in the disjunction one, it says the only, remind myself, the only FF is the F in a disjunction anyway. So it does work out. Okay. Remember, we're doing this without context first, and then we'll throw in some words. Okay. So let's just practice our truth tables first. I don't mean to keep moving that over. All right. This is a a conjunction and. So I'm going to keep the truth table for the conjunction and kind of next to this. It's also in this one right here, but let's just use the regular table for a moment. So what do we do first? We always write the P and then the Q and then any negations. So this is always true, true, false, false. This is always false, true, true, false. All right, negation of Q. If this is true, then this is false. If this is false, this is true, so on. Having pencil issues this morning. All right, then I'm ready for the P and not Q. So P is T, not Q is F. On my conjunction table, a T and then an F is an F. Okay. If you do it enough, you can use this thing up here. It makes a little more sense. But right now, I'll just use the basic tables that I have handy. So a P and a not Q. So a double T is a T. Okay. And F, this one, obviously you don't need this column, but when they're in order, you can just kind of put your finger over the ones you don't want. So F and F, F and F is a F. And then a P and a T is an FT, which is an F. So that's what these are. Okay. The conjunctive, remember the rule, only a double T is a T. All the rest are Fs. So however you want to understand this. And then you can throw in some parentheses. Remember the arrows are conditional. So the main thing going on here is a conditional. So I'm going to get out the basic table for conditional, the if then. Okay. So remember parentheses first, just like PEMDAS. So P, if P is true, then not Q is true. And then the whole thing is negated. So it's the opposite. So if all this is true, then this is false. So let's figure out what it is. So again, we're talking P, Q, true, true, false, false. Oops. Remember, these are the conditions. True, true, same every time. False, true, false. All right, then I need negation. I'm going to stay in the parentheses first. So I happen to do my not Q next. Excuse me, having a problem this morning. All right, not Q. If Q is true, then not Q is false. If Q is false, true, false, true. Okay, so that covers everything that's in here. So what I want to do is just what's in here first, which is the P. If P, then not Q. So I want to make a column with just that first. I find this to be the easiest. So P is T, not Q is F. And if I'm using the conditional, T and then F is an F. Okay. And then P, not Q, double T's or T's in conditional. Okay. In fact, the only thing that's a false is this combination right here, and everything else is true. P, not Q, true. F, then T, true. So only, oops, wait, I'm going to need another. So if you want to think about it as only TF is false with a conditional. But remember, we're negating the whole thing. So the last column is not, or is the opposite of what this is. So this was an F, so that's a T. F, F, F. That's my final answer right there. Okay. And this one, get my hand out of the way in a second. Notice that there's a couple of things going on. There's the, excuse me, there is the conjunction right there. And this is the biconditional, right? So I need all of these things. So I'm going to try to use this table here. See if I can put all this on this page with my pencil. Having issues. Okay. So I need a P. Always starting with a P and a Q. T, T, F, F, T, F. Weak lead today. T, F. All right, there's the P and the Q. Excuse me. Any negations? There's a not P that I need to use. So if this is T, then that's F. If this is T, F, T, T. There's my not P. All right, and then I want to do what's in the parentheses. Not P and Q. I'm doing too many videos. My throat is very dry. Excuse me. All right, so if you want to, you can get out the conjunction table for this one. All right, not P is F, and Q is T. So an FT is a F. So if you're looking at this table, an FT with a conjunction is F. Okay. Not P. F, Q, F, double F's in a conjunction is an F. Double F's in a conjunction is an F. So I'm going to push these up just a trying to see that at the same table. Double TF. Okay. TF. Wait. Q is a T. Just keeping track here. And a double T is a T. And a T and F. T and F is an F. Okay. Now, this last column is going to be the P if and only if this isn't, and well, that's hard to read. It's hard to say. Q all together. Okay. So what was P? P was T. What was all of this? All of this was F. Okay. So I need the biconditional table. Is this one? Let's see if I can move this over. Or I can use that one above. All right. It says TF is an F. Excuse me. I apologize. All right. This one, P is a T. In fact, you could just go, these are my P's. I mean, you'll get faster at this. And then this whole column here is F, F, T, F. Okay. And then you're looking at the biconditional, and everything that has one of each is an F. So that's an F, that's an F. And anything that has two the same is a true. So that's my final answer for that one. Okay.